Lucky, I haven't checked. Yeah, Jin Chang is here. Your boy also, is it? Same gang, huh? Same birthday, Maybe you guys are twins. Jin Chang, are you guys twins? Anyways, yeah, these are the key important things that you need to know, guys. You know, if you don't know this, gotta make sure you know by now. If not, I can always take a screenshot and send it to you guys. You know, do you want me to screenshot this? I think no need lah. You can search it on yourself lah. Then after that, longitudinal wave. This part here, where the waves are very close together, is known as a compression. Very good. It's known as compression. And the part that is very far apart is known as a rarefaction. Right, rarefaction. Basically, in your IGCSEs, if they talk about longitudinal waves, most of the time they'll ask you to explain what a compression is and what a rarefaction is. If you're talking about compression in terms of pressure, is it high pressure or low pressure? It is a region of high pressure. That's why the molecules are closer together, right? Whereas for rarefaction, it is a region of low pressure. That's why the molecules are relatively further apart. Very important. This is quite a standard question. If you've done some past year papers, you will know what I'm talking about, right? They always ask you to explain this. And one more common mistake among this question is that, you know, students sometimes when they see this rarefaction, right, they read it as refraction. Then tell me that the answer will be like, it is a region where the wave changes in terms of the speed, which is the exact explanation of refraction. Make sure you read the question properly. I've seen this, you know, the first year when I saw it, it sounded a bit funny. The second year, I see a pattern. The third year is the same thing. Fourth and fifth and sixth year is still the same thing. So make sure when you read, make sure it's refraction or rarefaction, yeah, boys and girls. So what about the wavelength? Where to where is considered the wavelength? Let me ask you this. Marcus, is here to here considered one wavelength? No, why not? Good, it is not repeating itself yet. It is from here to here. So if you started from compression, it will be two. Compression is one wavelength. If you started from rarefaction, then to rarefaction will be considered one wavelength. The key thing here you guys need to understand is that as soon as it repeats itself, it is considered one wavelength. Same for transverse wave, same for longitudinal waves as well. Okay. Now, in terms of transverse wave, there are two more key parts that you need to know for a transverse wave, which is essentially the amplitude and the frequency. What does the amplitude, what's the amplitude responsible for again, Chloe? The pitch, not exactly, that's the frequency. The amplitude is actually responsible for the loudness of the sound. Right, meaning to say if you have a wave that is higher amplitude, for example, this wave here, it will obviously sound louder, right? And frequency is the one that is responsible for the pitch, guys. In general, men will usually talk in a lower frequency. That's why it sounds a little bit more manly. And girls will usually talk at a higher pitch. That's why it sounds a bit more. Exactly. You know, so you always remember, guys, pitch is because of your frequency. You can always think that men are generally much lazier, so when they talk, they don't even want to talk with a higher frequency. They just talk in a low frequency and thus the low tone, right? And girls, they are generally a bit more excited. Is that word? Is that the correct word? Excited. You know, excited or whatever lah. That's why I talk at a higher frequency, or in other words, a higher pitch. Okay. Idiot. Okay, yeah. Oh, and one more thing, guys. Usually in your IGCSEs, they also ask you to explain a transverse wave and also a longitudinal wave. If they ever ask you to explain a transverse wave or longitudinal wave, you have to explain them in terms of the vibration and propagation, guys. I think I've mentioned this in one of the classes before, right? Anyone can recall what I've mentioned or not? In terms of vibration, how does the transverse wave and longitudinal wave differ? Oh my God, I can hear pitch silence. That's definitely not a good sign. Longitudinal wave will be something like this. Oh yeah. This is vibration and this is propagation, guys. Now, guys, for those who don't remember this, guys, if you're asked to explain in your IGCSEs, you will have to mention that for a transverse wave, the vibration is perpendicular to the propagation of the wave. Guys, for those who cannot remember the word propagation, right? For those who cannot remember the word propagation is just the direction of wave travel. If you don't want to write propagation, you just write the direction where the wave is traveling in. The direction of wave travel.
Instead of vibration, can I say like amplitude is perpendicular to direction?
Amplitude? No, is a totally different thing.
Must write vibration.
Yes, it is always vibration. Okay. All right. It is perpendicular. Remember, guys, the definition of a transverse wave is vibration perpendicular to the propagation, whereas a longitudinal wave will be the exact opposite, right? The vibration is parallel to the propagation. Very important. Always ask in your IGCSEs as well. Okay, so if you can do that, then we can attempt the question here already. Oh shit, were you guys copying? No. Yeah, okay. Then from here, amplitude of the wave, obviously you draw the equilibrium. You draw the equilibrium position first, and you say that this is going to be your amplitude, right? And the wavelength would obviously be either from here to here, or here to here, or here to here. Either one is acceptable. Okay. Then after that, they ask you to label the trout, which is obviously here. I think everyone should be fine, right? Okay.
The right one?
Yeah, either here, same. Okay. All right. Then after that, the next part, a person vibrates one end of the spring vertically and produces the wave. He makes 15 seconds oscillations, 15 complete oscillations in 60 seconds. What does this information give me first? 15 complete oscillations in 60 seconds. What information can I do from this here first? Frequency. Not exactly wrong, but you can find the period first. By definition, guys, period is the time taken. The time taken for one oscillation, time for one oscillation. Okay, period is the time taken for one oscillation. If 60 seconds were 15 complete oscillations, then you want to find a period, it will be 60 divided by 15, right? Which will give you 4 seconds. From the period, you can find the frequency, right? What's the formula to get frequency from period? F equals to? No, from period. From the period, how do we find the frequency? Good, excellent. It is 1 over period. Frequency is 1 over period, which is essentially 1 over 4, which is essentially 0.25 hertz. Now, guys, the frequency basically tells you how long how many oscillations it does in 1 second. If you see that it's 0.25 hertz, it means to say in 1 second it can only complete a quarter of the oscillation, guys. You know what I'm talking about? Like, for example, if the period is 4 seconds, right? This is 4 seconds. 0.25 hertz means to say in 1 second, oh my god, in 1 second it can only complete a quarter of the oscillation, guys. You understand what I'm talking about, right? So from here, once you have the frequency, you need to find the speed. What's the formula for speed in a wave? F equals to frequency lambda. What did you say just now? Yeah, correct. V equals to F lambda, guys. From here, you are actually supposed to measure how long this is, but I can't remember how long it is, but it doesn't really matter. Just write down the formula, right? Then you should be able to get it, right? Yeah, but you can't complete this because this was a full scale drawing, guys. Hey, be very careful when you see this in your IGCSEs. Full scale usually means to say you need to measure something off it, guys. But also be careful if it doesn't write full scale. Don't measure the wavelength and say that the wavelength is from the diagram. It doesn't work that way. You can only measure if there is a full scale. Okay.
And why in the question
tell you the speed of the wave.
Or they want you to show that the speed is this much. So by right, you're supposed to measure how long this is, multiply by your frequency, and you will have gotten this as your answer. By right lah. But because I scaled it down for you guys, you can't do that lah. Right? And for those who are online, you definitely cannot measure. VES, speed of wave.
The period, right, 60 over 15, right? Then you want to do it 1 over period. Right, then use 15 over 60.
Oh yeah, that's correct. You could use 15 over 60 to find the frequency straight away, but generally we like to follow step by step lah. Okay, then from here state the difference between a transverse wave and a longitudinal wave. You use your ideas of direction and oscillation, which is essentially propagation and vibration here lah, right? So this is essentially the things that you're supposed to write on. Transverse wave have oscillation perpendicular to the direction of travel, whereas longitudinal wave have oscillation parallel to the direction of wave travel. You're just supposed to show the working only. No, it's already given here. Yeah. Are you paying attention? Ignore it. I'm not going to explain it again. Ignore it. Just now explained so long, detailed, and then now asking me the same thing. Yeah, I'm just going to ignore it. Okay, everyone, any other questions from this beside from that one? Huh? Oh shit, it's perpendicular. Exactly. I was talking while I was writing this.
So the vibration or
yeah, oscillation and vibration are the same thing. Propagation and direction are the same thing. Write a little note down if you tend to forget, which most of you guys will, right? But it's essentially how it's supposed to define it. Okay, everybody. Try attempt question number 7. 10 minutes. 所以不行，12点半了哦。哇，去哪里跑？阿 K 的啊？哎。
4点的一个。
4点啊 ？What is he doing?
4点真的。
What are you guys doing?
看 YouTube。
谈恋爱啊？Very good. Hey, hurry up, do this. 10 minutes. Everyone, faster, start doing now. Let's explain to us. Tell her why.
So which one are those kind of?
Which one? Guess so. Which one? Which one is prettier? Tell me.
No, one man.
You. Which one?
This one.
It's the one. The one with the mask.看就好，我也不要讲那么多废话，4分钟啊，我want you write nothing 啊。 What?
Garden.
Garden. Garden.
More than living.
Garden and indoor. What the hell? What's your question? State and explain why electric socket and plugs used outside in the garden needs to be different from those that can be safely. Or yeah, it's more likely to get watered lah, right? So it's
What is
gonna
another?
state and explain, ma. So one point is your statement, the second point is your explanation. You don't have to write 2 points. You need to state 1 point and explain that point. Okay. What the
fire spurts out from them.
Hospital ah, 跟我控啊，是係你啊，埋你啊。I think he's scoring better in physics. No. Finish everything on more. Chloe here, how are you doing in physics? Struggling a little bit. The whole section of year 10 maybe? Good luck. When's the results on? You say the section that you did not submit is part of the test, is it, or assignment? Oh, sorry, what? Oh, still use of medicine. Man, just now we talked about it. What's the thing called again? No. Endoscope. Endoscope. What's it used for? View what?
But how do you write this detail though? Like the light travels through the optic that's reflected somehow.
Oh, you don't even explain so much, right? In the real exam, right? You just need to say that endoscopes are used in medicine, right? It is used to view internal organs for keyhole surgeries. Then can read.
What keyholes?
Keyhole surgeries. Then can read. Two more minutes, guys. Make sure you write something down.
The endoscope maximum to the stomach. And the goes on down.
Want to go try? But to my understanding, it's to the stomach only. But we can always arrange for something in the hospital. For the name of science, we say this is a school experiment. I go to the hospital and say, can we play with this? And you will be the human subject. On. Let's go. I never tried before.
The whole school whoever the naughtiest of the school.
Of course, not the naughtiest. The naughtiest don't care. You must go for the ones that like somewhere in between one. Like maybe you. Huh? What is meant by monochromatic light? Use one of the following. What is monochromatic light? Do you know? Laser is a form of monochromatic light. They have single what?
But then here don't have wavelength.
So you choose the next option. Would it be possible single amplitude or single, what the hell was that, brightness?
Refractive index.
Of course not. Do you even know what's refractive index?
No.
Frequency lah. Monochromatic light is single.
Wavelength.
Frequency is amplitude or wavelength. Frequency is wavelength. Is it? Then why don't we call it wavelength? Why do we call it frequency?
Cos, sines. I don't know. Wavelength.
Yeah, so it's a different thing. Okay, guys, let's go through the questions together, everyone. I hope you have attempted this paper here. Hey, guys, I want to highlight this again. I think I've said this before, but I will definitely say this again. In your exam, guys, if you see this, right, sometimes the question, they don't give you this line and this line, you know, they'll ask you to draw the lines inside. If they ask you to draw the lines inside, and I know some of you guys are going to draw something like this, right? Can you do this? Definitely not. Why? Because total internal reflection has to follow the laws of reflection, meaning to say, however much this angle is, this one must be however much this angle is, this angle must be this as well. In optical fibers, especially in your IGCSEs, don't draw more than 2 light rays in the optical fiber. Usually, in most of the cases, it will actually just be 1. But the mark scheme is lenient. They'll give you up to 2 lights, right? Don't draw more than 2. Very important. It always comes up. Anyways, moving on to this one here. State the name of the process which occurs. Obviously, this is known as photo internal.
If I don't write that, you know.
Yep, definitely. If you just wrote reflection, it is absolutely wrong, guys. Optical fibers are not reflection now, it is total internal reflection.
Also in reflection is just the same.
To my understanding in your syllabus, yes, but the condition for total internal reflection to occur is always from more dense to less dense. Like for example, you know, if like you guys all know how to swim, right? Any one of you guys don't know how to swim here? Okay, so
Do you know how to swim?
of course, this is like the #1 skill you learn, bro. So anyways, if you ever been into a swimming pool before, right? Let's imagine this is the swimming pool, right? And then sometimes when you look up to the swimming pool, you can kind of see the tiles on the ground. Have you guys ever experienced that before? That is known as total internal reflection, because here is obviously more dense and here with the air, which is obviously less dense. When the light is traveling from more dense to less dense, for sure is total internal reflection, just like optical fiber. Inside the fiber is glass, which is more dense. It's coming out to the air, but it cannot come out, which is less dense, so it's total internal reflection. But if, let's say, right, you stand on top of this swimming pool and you piss onto it and you see your reflection in it, right? I mean, you're not going to piss on the swimming pool, right? But let's just say, you piss into the swimming pool and you see your reflection. Is that called total internal reflection? No, this is just normal reflection. This one here, normal reflection. This one is total internal reflection, guys. Okay, very important because this one is from less dense to more dense, which is essentially your mirror, right? Your mirror is definitely more dense than the air, right? You stand here, you look into the mirror, you can see the reflection. From less dense to more dense, that is known as normal reflection. Okay, very important.
So internal is more dense to less dense.
Yeah, from more dense to less dense is known as total internal reflection. Yeah, if you're in the pool, you see the reflection of the tile, that is total internal reflection. You're standing on top of your own piss and you see your face. That is called a reflection.
How is it like total internal reflection inside the fiber? But it's like all the same one.
I just said it just now.
Is it like more than some part?
This is glass, right? Is this more dense? This is air, right? Is this less dense? Because it's going through total internal reflection already. Just like in your swimming pool, it won't reach the air, but it can, but it won't. But it doesn't matter. Don't think too much about it. Just understand that this is total internal reflection. Oh, very good. Very good. Okay, then after that, this one here, they give us the refractive index already. This one here is going through total internal reflection. There's 3 formulas, right, for refractive index. What are the 3 formulas again? Yeah, what's that formula called? What the? Was it? Huh? Wow, I don't know what name is it, but what's the formula? Good, it is sine I over sine R. Some more, what's the next one? Good, what's the third one? Next already. Tap out loud. Who's tapping in? Oh, boy, this guy already provided 2 already. What's the last one? Tatao. Laka semua. Sign again. No more sign. Mathematics, is it? What's the next one? Everyone's like, don't take me. Wow, học嘢啦你哋 C over V, very good. This speed of light, which is 3 times 10 to the power of 8. This is 3 times 10 to the power of 8. Then this is the speed that is inside the medium. V is speed of light in the medium, like for example, the water or the glass or the whatever, the plastic or whatever. In medium. So which formula should we use in this scenario?
3 times 10 to the power of 8.
Yeah, meters per second. You should know this by now, huh?
1/sin C.
Good. You're supposed to use 1/sin C. Why?
看得清。
Because this one here is going through total internal reflection, right? For total internal reflection to occur, it must exceed the critical angle. Very important, it must exceed the critical angle. Only can it go through total internal reflection, right? So from here, you don't know what's critical angle? You know, when the light shine here, then it goes through maximum refraction. This is what I call total critical angle.
How do you not get to the point?
You decrease the thing, you decrease the angle of incident, then you go through refraction. Okay, then beyond the critical angle is total internal reflection. So there's refraction, there's critical angle, there's total internal reflection. 明白吗? Critical angle. Hey guys, this also comes up very often now. They'll ask you when can you reach critical angle. Your answer is always maximum angle of refraction. Maximum angle cannot refract anymore already, right? It's 90 degrees already. Beyond 90 degrees, it's considered total internal reflection already. So yeah, so from here, obviously you're supposed to use the 1/sin C. And your angle would have been somewhere around 46 degrees, I think. Right? Do you guys get somewhere around 46 degrees or not? Yeah. 46.5. Huh? Oh, okay. Yeah.
1/sin 1/4.
Yeah. V is speed of light in the medium. For example, your glass, your.
Then there is one more thing that you taught about the speed of something like in the air, solid one, like times 10 to 5.
That one is sound, lah,
Sound also 330.
330, then 1,500, then 3,000. So it's times 5 and times 10 from the original. All right. Then after that, state and explain the use of optical fibers in medicine. This one is a standard question, guys. Every year, if they ask about medicine in optical fibers, it's always going to be endoscope, guys. Endoscope are used in medicine to view internal organs for keyhole surgeries. Keyhole surgeries, right? Like the whole of the surgery is just like a key, that's why it's called keyhole surgery. Yeah, in the newer generations of appendix, they use keyhole surgeries. Really. Last time when we were younger, they cut quite big on. And as you see the progression, like my uncle who did his appendix was like probably 1 finger length long, and mine is like this long only. Then now I see it's like this short, and in the future maybe it will be even smaller because of the advancement of technology.
They put the endoscopes inside.
I think in appendix usage, it will be like they cut a small hole, they shove the endoscope in to locate where the appendix is, and then after that they'll cut it off, right? But don't take my word for it. I'm not a doctor. It's just my understanding. Maybe it could be possible with the newer technology. I think they will. But of course, don't take my word for it. Do your own research. Okay. Then finally, the last part here, monochromatic light. Guys, examples of monochromatic light are basically lasers. And if they ever ask you to define a monochromatic light, it could only be one of two definitions, either waves with single wavelength or waves with single frequency, either one only. Okay. And because of that, obviously it's going to be frequency and state. What is meant by monochromatic? Use one point one. Oh, waves with single frequency. Yeah. 2 marks. I don't know why. Stupid. but it is what it is. Okay, everyone. Attempt question number 8 right now. Oh, I don't think you need 10 minutes for this, by the way. You probably need 5 minutes or 7. Let's go with 7. 1:30. Hey, just now the other girl that was with you, was that your sister? How was your sister? Older. Oh. Oh, I can see that. Oh, my plants look like a sister. I don't know. One of the age. Because I think it's a dumb thing. It's Tristan trying to be funny with me. Instagram. Which one was you again? Just now, but it's gonna be a good one. You know Instagram? Decision makers. They did it in the back pages. This, we can do my best. Yes. Okay, everyone, I think you should be done with this question, right? I think not that hard to explain. Mishan. I need to. Okay, yeah, let's go through this question real quick so that we can tackle the other two questions. By the way, most of you guys have completed the radiation chapter as well, right? From St. John. You guys? This one done already, right, you guys? We are not done here yet, so like probably the next few weeks we'll be covering this. So don't miss the Monday class. Okay, let's go through these questions together real quick together. What do they want? State and explain why electrical sockets and plugs used outside in a garden needs to be different from that can be used safely in a room inside the house. I mean, this one is logical thinking, right? I mean, why wouldn't you want to have the same plugs outside? It's because the garden is going to be subjected to watering of the plants, right? And if it's watering of the plants, obviously it's going to be wet, right? And when it's wet, electricity and water don't go well together. You know, there was a story recently. This farmer from Kedah, Terengganu, or some state that is not so predominant. But anyways, this guy here, right? He was taking a shower as normal, right? And then suddenly one of the electrical sockets or one of the wires is like loose already, you know. Then while he was showering, the electrical socket or whatever wiring was loose and it's electrocuting him. Then he's like shaking already, right? He's like really like the movies like already, right? Then the wife came in and saw like, oh my God, my husband is shaking. You know, like Elvis Presley, the kind of scenario already. Then after that, she tried to grab him and pull him away. Like, oh my God, when as soon as she grabbed him, and thus both of them died together. When I saw the news, right, I was looking at the picture of their electrical heater, which was the cause of the thing, right? You know what they were doing? You know, like electrical heaters, that's like, let's imagine like this is the electrical heater, right? Then after that, there's like some wires at the bottom here. They're hanging shit on there, you know? It's like I see them hanging like the plastic bags here. Then obviously when there's a plastic bag, you're gonna put more and more and more and more shit inside. So I'm thinking, right? What happened was the plastic bag was getting heavier and heavier and heavier. Yeah, and you pulled the wire and then they effectively killed themselves. But the sad part is the kid was just like 5 years old only. Oof. And both the parents died in the shower. One was. She was definitely panicking, for sure.
Then in that situation,
let me tell you, in the situation, what you can do, okay? In that situation, you can either, number one, find an insulator and you really give him one good smash and you smash him out, right? But try not to smash his bones while trying to save him, right? Usually what they'll do is, right, they'll put like the wooden plank onto the corner and then you like want to body slam him, you know. Why this is so is because when you body slam him, you're subjecting him to more area, so that you just like smash him and something breaks along the way. Yeah. Alternatively, you should run to those, you know, like the fuse boxes at the bottom, like the back there. Yeah, just plug all the way off everything. Then it would maybe save his life, but you know, we never know.
How did they find them?
Maybe the kid called 911. Hello, police. I don't know.
my parents are shaking.
My parents are vibrating like my phone. But that's not a joke, don't say that. You know, but you know, yeah. But anyways, just be very careful when you see all these kind of electrical scenarios, right? Always remember, don't touch that guy because you're not saving him, you're just killing yourself. Don't touch that guy, you're not saving him, you're killing yourself. Okay, so from here, obviously you can write out anything like your state and explain. Your statement is obviously going to be the garden garden is usually subjected. It doesn't have to be word by word. Anything that's logical is acceptable or subjected, usually subjected to wet conditions. More insulation. You probably need like more insulation, more waterproof or water resistant or whatever waterproof sockets are needed to prevent shock. Anything logical? Right. After that, then explain why fuses and circuit breakers are installed in electrical circuits connected to the main supply. What's the usage of a fuse and a circuit breaker again? To what? What? Good, very good. Yeah. Good. So basically, the fuse and the circuit breakers are used to prevent excessive current from flowing, right? When excessive amounts of current flow through the fuse or the circuit breaker, it will break the current and, ultimately prevent you from dying, right? So your statement is obviously to prevent excessive amounts of current from flowing into the electrical circuit, protecting them from blowout. Yeah, okay, acceptable. Yeah, really. Anything logical, just say something that makes sense and you will get your marks. Okay. Once you're done with that, you can start copying, you can start attempting the next question. 10 minutes as well, guys. When they smash the 1,000 pieces, they're still attracted to each other. It's like theory only, no, it's theory only actually. All this I tried it before already. I haven't heated it up before, but the hammering one was a bit more interesting to me. I tried the hammering.
When you heat it up, then you also lost its.
Yeah, by theory, yes. If you heat it up, you're supposed to lose its magnetism. By theory. You want to help us clean?
Probably 10 dollars per hour.
Oh,
Was way too low.
low. Do you know what's market rate?
10 ringgit per hour, very high already.
The market rate is 5, by the way.
I'm expensive. So if you raise it up to 20 per hour, I might consider it.
Nah, that's too much.
But I thought you guys are hiring for me.
Yeah, we are supposed to hire the mates. But we say like that.
Because it's like not a big role.
No, it's because of procrastination. 6 more minutes, guys.
Didn't even write anything at all.
米山，该考试了啊，米山。
This is on 19th.
19 of May.
Yeah. Làm có lúc này.
这是我写出来的一个唯一不能录。很多人想视频。没找到。
3 more minutes, boys and girls.
What's the latest news? What's the latest news these days?
Latest news? Amber Heard. My girlfriend was telling me she was watching Amber Heard in court for an hour a few nights ago, just to catch up with the news. So dumb. So dumb, man. Seriously. She's just a psychopath, honestly. Easy psychopath.
You spend like 1 whole hour talking about nothing and
Muffins.
yeah. Something about running that bought like nothing for her and then
Psychopath. Just a psychopath, man.
what are the reasons?
They say that domestic abuse mostly is from women, isn't it? Look at him. He's smiling already. He's like,
Asking for help.
俾人打得少啊你。
冇面啊你。
Yeah, but yeah, they do say that domestic abuse is more on women abusing the men, but the men will never win in the court because it's very hard to believe that men are victims of women. But the truth is, women psychologically attack men. Who's winning? Johnny Depp for sure 赢了 ，for sure 赢了，因为真是他，Amber 他是一个 psycho 来的，你知道吗 ？Like
I thought this is the second one. The first one is Robert won.
係咩
Second, this one is second one. This one is
Is
Johnny
it?
Depp. Sue.
I don't remember. I didn't follow the story lah, but I just know it's like a really dumb one. And then it's just put up. I don't know how to explain. Okay, anyways, yeah, let's go on with this question. I think everyone is mostly done, right? Mishan, 有沒有做啊? Pay attention, everyone. Hey, you better practice more. I see like most of your questions are empty one. How are you gonna go for the exam? Okay, if you look at this question here, what do they want? Draw an arrow on each of the 3 compasses and plot B, C, D to show the magnetic field. Right, first and foremost, the only information given to you is this, right? This is the only information given to you, and obviously this is the north and this is the south, right? So what pole could this possibly be? South. North, for sure, and this is obviously going to be south, right? If you have identified this is north and south, the next thing is you want to identify the magnetic field lines, right? The magnetic field lines will be something like this lah, right? Right. So from here, obviously, when you draw the direction, this one will follow the direction, and follow the direction here, ma. Because the stronger magnetic field will always influence the weaker magnetic field. In this case here, the stronger magnetic field is from the bar magnet. The weaker magnetic field is from the compass itself, guys. So this is how you're supposed to do this kind of questions, and label it N and S. Then after that, describe one method to demagnetize a magnet. What's the 3 methods to demagnetize it? First one, Mishan. No lah, it's supposed to stroke it, right? You're supposed to stroke the bar magnet. Everyone start getting excited already when I say the word stroke it. You're supposed to stroke the bar magnet. If let's say this is the magnet, you're supposed to stroke it with another magnet, and then eventually it's going to demagnetize, right? Because you're destabilizing it, ma. The second method is what? Yeah, you either. Oh, sorry, stroking was to magnetize it. Sorry, forget what I just said just now. The 2 methods are going to be number 1, you either heat up the magnet, right? So it's so hot that the magnetic domains vibrate into different directions. Or the second one is you hammer it, right? If you hammer it, eventually you're going to force the magnetic domains to point in random directions and destabilize the magnetic field. What's the third one, including current one? How do you use current to demagnetize a magnet?
Use a current that goes opposite.
Yes, it's called an alternating current. The alternating current that keeps feeding in and forth to the magnet will eventually demagnetize it, right? So you can write either one. For me, I'll definitely write hammering it. Hammer.
For the alternating current one, you want to wrap the coil.
Yeah. Oh, by the way, for those who are wondering, does this actually work? I've tried to hammer it before. I smashed the magnet into 1,000 pieces, and that 1,000 pieces were still attracted towards each other. So the theory sounds good, but the real thing, maybe I did it wrong. in the
West east what?
west-east direction. West-east direction. Huh? Miss? Nani?
How we know that the farmer's A is south and north?
How do I know it's south and north? Looking at the arrow lah. This here is pointing this direction ma. So this is for sure north and this is south, right? It's a
North to south.
it's a 指南针, right? Is it called? 指南针 in Chinese it's called 指南针, right? So whatever it is, I don't know what it's called in Chinese. But anyways, by right, a compass is always going to point towards the north direction. The so-called north direction is actually the magnetic south of the Earth's polarity, right? So from here, I know for a fact that this one is for sure north and this one is for sure south from the pole, right? From here, I know that only way for these two to attract is for north and south to be together. And from here, I need to know that the magnetic field always goes like this, right? Then that's how I determine the rest of the magnets. You got me, no? Does that answer your question? Is that what you're asking? Okay. Anyways, moving on to the next part here. Figure 9.2 represents a current in the wire. The current is in the plain paper. Draw the pattern of the magnetic field. Clearly show the direction. X means to say the current is going in or out of the paper. Marcus is going into the paper. What if it's going out? What should you draw it as? Same. Then how do I know when it's going in and when it's going out? The dot. Oh, it's the dot, right? X means to say the current is going in. The dot means to say the current is going out. If it's going in, you're supposed to use which hand rule again? The right hand grip rule. Your magnetic field is going into the paper, and thus your four fingers will be rotating in the clockwise direction. Right. Make sure you draw at least 3. It's required in the marks team that you at least have 3 circles. And the circles should be further and further and further apart. Right. Then finally, the last question here. The direction of the current in the wire is reversed. The magnitude of the current is unchanged. State the effects that reversing the current on the magnetic field produce. Obviously, is going to reverse the direction of the magnetic field as well. Reverse the direction of what? Right, and this is how I'm supposed to attempt these questions here.
The dot is out. If the dot is out.
If it is dot, then it means to say the current is coming out. Means to say you're supposed to draw it in the clockwise, in the anti-clockwise direction instead. Yeah, also right hand. Just that the current is going up, so your 4 fingers are rotating in this direction. You know, right? No, you're not supposed to use that. That's Fleming's left hand rule. You're supposed to use this. It's either going in, right? In means to say the current is going to like clockwise, or it's going out of the paper. Then your magnetic field is going anti-clockwise. Okay, question 10. One of my favorites. The circuit questions. Let's do it. 10 minutes. I think next month or the month after that. I'm in thermal right now. Yeah, talking about what's it called, the Q goes to MC data chapter. If you guys want the video, let me know. I can send it to you, but make sure you watch it. Like I said, help me, help you, help me, help you, help me.
What video?
Of the year 10 class. Of me explaining the Q goes to MC data. Q goes to MC data. I remember the one we did yesterday. It's a latent treatment. Yeah, this is quite good, person.
Last year.
Last year, basically. One more thing I heard from the podcast, guys. You know, yesterday how I was talking about this Jim Quick podcast. This guy, right, he says that if you want to learn something faster, you teach it to other people, whatever you know. Seriously, that's what you know. Whatever you know, of course, not whatever you don't know.
Maybe this one is like this. Maybe it's like that.
That's IOS. You meter prep like that, man. Are you sure? Are you sure? I didn't get the biggest one. That's very hard. I think these probably very annoying. Sorry. I didn't know the biggest one. I wanted the smallest one, but they say the battery was shit.
All is just the.
Or was it 12 punya atau 13 or mini or I didn't follow. It's 12.
All the others.
You know what's the difference?
Have
The marketing.
Yeah.
Honestly, Apple is great at making you think that you have a perfectly fine product, but you need to buy the newest product. The double is here. Baby, don't you know? The other doubles is here. This one. What? It's not good. Yeah. For about 5 more minutes, boys and girls. Kristen's girlfriend. Yeah, it's friends, okay. Yeah.
The voltage in parallel is same right, but it's like
These two have the same voltage, but these two will have different voltage from this one.
so like now I need VIR and use.
4 marks question or looking this online.
Yeah, no, it's not easier, but I'm not gonna use 5 volts.
Where is the 5 volt from? Where is the 2 volt from? I mean, 2 amperes is here. No, this is 5 and this should be 5. So if these two are 5, we're going to find out how much resistance both of them are added together, then we know how much this one will get.
But then the 5 volts.
No, these two are 5 volts, 5 volts. But these 5 volts will be only a portion of this original one. So whatever is left of this original one is here.
So now I got this 5 volts already, I find the total resistance.
The total resistance from this circuit. Actually, you don't even need to do that. This one is how much? 2.5 amperes, right? You double up the resistance, how much would the current be?
Double is double. Are you sure that's how it works?
When you double up the resistance, you're telling me you'll double up the current here as well.
Minus.
Yeah, how much? Yeah. This current is in this line. So this line plus this line will be this current now. Can you imagine on the 2.5 is current here, 1.25 is going here, that's what then add up together will be this current here. Then you find out how much it is.
So this 1.25 is here.
No, bottom line here. This
Then
thing
you need to
here,
add up with
you add with the one on top.
Then it
minus.
becomes 2.1, 2.1.
Yeah, plus 2.5.
It becomes 2.1, but
Do it slowly. Think about it again. Wow, see, most of you guys are stuck with this question, huh? Really?
This is the hardest. School teacher around page lah.
School teacher 6. Yeah. No, just joking. Cool. God, it's recorded.
So you don't teach our school.
Okay. I will only do part-time only. I want to go there, teach, and then go off already. The request from your principal can.
This guy actually got an offer from what is it called? MLC last time.
Yeah.
Let's see.
No lah. It wasn't lah. They wanted
No
something else.
salary.
Yeah, serious. They
See, you're
couldn't.
not even wearing long pants on here, bro.
It's Sunday, bro.
Casual.
It's Sunday, bro. It's for Jesus.
Thanks for Jesus.
Yeah, Sunday is for
Actually, we're
Jesus.
sacrificing our day for Jesus for you guys today.
Yeah.
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 Well,
You believe in Jesus?
you don't believe in God. You're good at hell, you know that.
I don't believe in God and hell will exist.
Huh?
Alexei.
No, we want to save you from
I'm
hell.
a nightmare of Satan.
Ooh.
Ooh, you're a lap dance for Satan.
Ooh. Okay, guys, let's go through this question. I see some of you guys are struggling with this, and I see like it's no progress all the way, guys. Oh my God. Let's start off with this one here. Okay, so what do they want from you from this question? Good. First and foremost, figure 10.1 shows an incomplete electrical circuit. A student completes the circuit and measures the current in the 6 ohm resistor. On figure 10.1, draw an ammeter symbol in one of the gaps and straight lines to indicate wires in other gaps to show how the student should do this. So obviously, you want to find the current here, right? You want to find the current here, ma? Oh God. Find the current here, you don't know what is it, but you know for a fact that this line will be the same all the way up to this line here, right? You guys know this, right? So from here, obviously, you want to find an ammeter, put it here. This ammeter over here. Then after the other straight lines, you just need to draw wires only, ma. Some of you guys, I see you draw voltmeters here. Some of you guys, you draw ammeters here. Don't overcomplicate it. They only want you to draw wires, so you just complete the line, and you're done. Right? You would have successfully found out the ammeters, the current in the 6 ohm there. Right? Then only the next question they ask you to. A voltmeter is connected to measure the potential difference across the 4 ohm resistor. Draw a voltmeter. Obviously, voltmeters must be connected in parallel, right? What's the reason you connect voltmeters in parallel again? Why can't I connect voltmeters in series? What thing? The resistivity is too high, guys. Imagine today, if I connect a voltmeter here, right? The resistance of a voltmeter will be so high that all the voltage will be drawn here, right? So there will be 0 voltage here, and 0 voltage here. The same reason why you cannot connect an ammeter in parallel. If let's say today I connect an ammeter in parallel like this, because the ammeter is so low in resistivity, all the current will flow like this and thus ignoring all the components inside. Voltmeter, high resistivity. Ammeter, low resistivity. That's why we connect them in series and parallel. Okay. Then after that, the calculation part. How many of you guys got this answer, by the way, the calculation part? The answer is supposed to be wow, 3.8 amperes. How much? 3.75. Ooh. Is he the only one? None of you guys got it up. And the girlfriend, of course. I mean, right. Anyways, hey, look at this question. This here is basically the understanding of parallel and series circuits, guys. First and foremost, the first piece of information is this, right? They say that the 2 ohm resistor is getting 2.5 amperes already. This guy here, there is 2.5 amperes flowing here, right? With this information, you can use the Ohm's law formula, right? What's the Ohm's law formula again, Mishan? V equals to I what? 你石头啊 IR 大佬 V equals to IR, right? Which is essentially going to be 2.5 amperes multiplied by the resistance of 2 ohm. You'll get 5 volts here, right? From here, first things first is you know for a fact that there will be 5 volts here. And the 4 ohm resistor will get how much voltage, Marcus? How much voltage will the 4 ohm resistor get if there's 5 volts in the 2 ohm resistor? Sorry, how much voltage will the 4 ohm resistor have? 8, 10, nani? This is a Russian roulette game, really. Is it spin the wheel and then blabber out some numbers? Oh, these two are parallel to each other, right? If they are parallel to each other, how much voltage should they get? They should be the same lah, 5 volts. What about this one here? Is this guy going to get 5 volts as well? Definitely not, because they are in series, right? So there are a few ways you could do this. If you want to find out how much current is flowing here, number one, I could do it the hard way, and I find out how much is the total resistance here, and I find out how much is the voltage and how much is the current. Or I could use some logical understanding to know that if, let's say today this is 2 ohm and there's 2.5 amperes flowing here, if there is 4 ohms here, it's double up the resistance, right? When you double up the resistance, what would happen to the current? It will be lower. By how much lower? Half of it is gone, all right? So I know for a fact that by right, there's 1.25 amperes flowing here. If there is 1.25 amperes flowing here, then flow here, this has to connect with this one here, right? Eventually, how much current will be at the 6 ohm? Good, which is 3.75 amperes, guys. It's supposed to be 3.75 amperes. Wow.
Wait, current is a piece of cake.
Parallel current is the cake, voltage, series is the cake. Sorry, series voltage is the cake. SVC, series voltage is the cake. PIC, parallel current is the cake. Yes, the cake. You guys didn't come for the class, right? It's a secret story of Mahathir also. Both of them same, old sly dogs. Oh, it's recorded. Later I get sued. Hello? You said this in... No. Okay. Anyways, you guys get the drill, right? You're supposed to do it step by step, guys. Actually, you don't even need to find the voltage. But look at the mark scheme, it's like super long working. Oh my god, I don't even know what's going on here. Yeah, just ignore it. That's why understanding is more important than memorization. Please make sure you understand what's going on. Then you can tackle the questions one by one. Oh, it's not done yet. So anyways, your final answer should be 3.75 amperes. Oh, anyone still copying?
So the current is the AD side is also 3.75.
Yeah, for sure. because the 3.75 has to split 2.5 up and 1.25 down. Okay, moving on to the next page. Figure 10.2 shows the same electrical circuits with an alternating current power supply. In 10.2, draw a diode symbol in one of the gaps to indicate a wire in the other gap so that the current flows from right to left. From right to left of the 4 ohm resistor and an alternating current on the 2 ohm resistor. Hey, this one I think everyone should know how to draw, right? What's the symbol of a diode again? Yeah, so we're triangle on one line. Should the triangle be facing the left or should it be facing the right for the 4 ohm resistor? It should be facing the left. Right. Then this one just draw a wire. Then you get your marks. Easy.
Why is that?
Huh? Because the question wants the current to flow from right to left. Okay. Final question. 10 minutes, everyone. Then let's call it a day already.
This one just 2 marks like that.
3 marks. Easy. Last 10 minutes, guys.
Fission is the separation of molecules.
Fission is separation. Fusion is combination.
What is it? Molecules separation of
Nuclei. What do you mean? Oh, when? 你幾時仔俾佢？佢幾時開張？幾時？
Wait, why is not L? Delta. What's delta?
Charlie, Angel, Delta, Fox, Gamma, Beta. That's the easy, man.
Right?
That's the easy.
His cat markers couldn't see.
Yeah, some more as well.
Is it?
But I switch on all the
Who's successful position?
Burning.
Celebrate Mother's Day. All of you know celebrate Mother's Day. Okay.
Oh. Yeah, maybe that's the reason why.
Useless kids. Oh yeah.
Because they say here is more fun. Mother scolding you guys at home, right? 對，I 找我拜拜，翻學。
if you guys plan to go out today, good luck. Everywhere is damn crowded. Supposedly.
有層好緊要塞車嘅。
冇地用自己用。
你知道我哋 walk around Tropicana Gardens for so long, you know, like we couldn't find anything. It was like I was there since 7 o'clock. They say every restaurant I go to earliest is 8 o'clock for slot, not food, for slot to sit down and then wait for food. Okay. Terror yesterday. I like her. The physics is quite good.
Who is that?
Tristan.
Oh, Tristan.
Yeah.
Hey, what's her name? Good Tristan over there. 走。但是学生不，我们是不也不不，说我们是不阿妈，但是不阿爹，我们家不爹。So my first came into my class and decided to stay.
你有觉得你要 leave 吗？听了这个就过后。
这是我蛮给的。哎呀，是。
By what? Oh, yeah.
Did you also buy Windows software?
Yeah. It was $2.
So we all spoil our now.
Somewhere around the answer.
But even if yours was like pirated on, right, then you can still update to.
Yeah. This laptop one obviously wasn't fake lah. Desktop one are usually the ones that are fake.
What is the real one?
It is a real one. Calling Jack Sparrow lah, without the amber heart only. Or is it? With your heart lah, of course, 用心的嘛，对不对？ Yeah.
Dear Heavenly Father, forgive me for this week. I've been many.
喂，empty 啊，喂。
I know that I will forgive that next week.
死啊！你兩個，你講考試我係兩條。
I know that whatever I do, I message from people because I hear
Hey, I think you seriously lack a lot of exercise. I think for most of the time, just dreaming, right?
Yeah, but you just go there.
But when you answer the ABC questions, you can answer one more.
do at home.
Or then they give like net, they will pay money.
Google, I always just put my
Oh, you finish already, not so much, 但是给啦，冇 disturb 佢哋。Okay, guys. I think let's go through it. I think some of you guys are stuck already, right? Yeah. Let's go through this question. Hey, for those who do not know what nuclear fusion and nuclear fission is, fusion is basically two smaller nuclei combining to become one larger nuclei, which releases massive amounts of energy. Usually this occurs in the sun, yeah, guys. You know, like how the sun is burning all the time. It's because nuclear fusion is consistently happening on the surface, and then it burns and burns and burns and burns and burns and burns, releasing a lot of energy. Okay. Whereas fission, now wait guys, fission is one I only. Is it? Oh, fusion was one S. Fission is double S. Whatever. Fission, fission is the exact opposite, guys. If fusion was the combination of the atoms, fission is the separation of the atoms. So usually it's like one bigger nuclei separating into two smaller nuclei, right? Which also releases some neutrons, which also releases energy, guys. But the energy scale is much smaller compared to fusion. This nuclear fission will usually occur in your nuclear power plants. You know, like uranium, plutonium, all those energy power plants, right? They are basically going through nuclear fission. For those who do not know, why don't we use fusion instead of fission on Earth? Is because of our limitation of our technology, guys. We have not been able to harness the power or the energies to use fusion here. Meaning to say, even if we were to successfully make nuclear fusion on Earth, the amount of energy that you put in is like maybe 10,000 joules. But the amount of energy that comes out is like less than 10,000 joules. Maybe it's like only 7,000 joules, you know. So we can do nuclear fusion here, but it's not scalable. It does not produce any energy. But for nuclear fission, it's the exact opposite. You know, we put in, obviously, we're going to put in some energy, right? Maybe we can only need to put in 5,000 joules. But when it comes out, there's like 10,000 joules here. That's why we are only doing nuclear fission at the moment. But if you look at some scientific research and everything, they're starting to develop nuclear fusion on Earth with the particle accelerator and whatnot. But I think we are quite far from there, at least another 5 years, unless Elon Musk steps in, then maybe it'll be a different story, you know. But yeah, this is essentially what's going on, guys. So if you're asked in this kind of question, just state two differences between nuclear fusion and nuclear fission. You can write any one, right? You can say that fusion is the combination of two nuclei into a larger nuclei. Fission is the separation. You can say that fusion produces much more energy than fission. You can say a lot of things, but let's stick to the basic ones. Okay, let's just say that fusion is one I or two I. One I. Fusion is the combination of two nuclei.
Can it only be two?
Yes, it can only be two. Fusion produces much more energy. I don't want to. Oh, sorry.
The first one, nuclear fission, the separation.
Yeah.
It's chain.
Chain reaction. Let's see. Chain reaction. It's not stated in the mark scheme. But I know what you're trying to say is the neutrons and then bombing into other one, then bombing into other, bombing into other one, right? But the thing is, fusion is also a chain reaction, if I'm not mistaken, because the heat and pressure generated from the fusion causes the other ones to raise in apparent fusion. So I don't think it's a difference. The mark scheme gives quite a few answers. It says that nuclear fission is larger mass, nuclear fusion is smaller mass, nuclear fission is in the nuclear reactors, fusion is in the sun, fission produces radioactive waste, fission makes light element, fission is normal, fusion produces more energy. Yeah, but I think let's just stick to the basic ones that is very easy to relate to real life, right? Combination and produces more energy, for sure. Okay. Then the next part here, radioactive traces emitting gamma rays can be used in medicine. The half-life of a source of these gamma rays is 6 hours. Explain why a source of gamma rays used this way should not have a half-life shorter or longer than 6 hours. You know what's the application of this, guys? You know what are radio traces? Let's imagine today, right? Let's say I have like a blood clot or cancer or whatever in my veins, right? they'll actually inject radio tracers into my body, right? And they'll detect where it flows. You know, so like it flow, normal, until a certain point where it's blocking, right? Then it is going to be stuck there, and the tracers will be like, if you take the scanner, right, it's going to like, it keeps detecting that it's stuck there already, you know. These kind of things are, it should always have a shorter half-life, because if it has a longer half-life, we are putting ourselves at risk, right? Imagine today if the half-life of this radioactive tracer is like 12 hours. Wait, after 12 hours, only it decays by half. Another 12 hours, it decays by half. What if it is poisonous? What if it is radioactive? What if it's dangerous to us, right? So why should it be not shorter than 6 hours? Because if it is too short, before it reaches the designated point, it already decayed away already. You get what I mean? So it's like 6 hours in between the sweet spot there. So if you were to write this down, you will say that
So the half-life is like the time where it needs to break down
to half. It will decay to half.
Break.
Yeah. So if like it starts off with 100 counts per minute, after one half-life it will be 50, after another half-life it will be 25, after another half-life it will be 12.5, another half-life will so on and so on and so on and so on. So this
becomes zero, then
it will never become zero, because no matter what, you're only dividing it by 2.
then it will forever be hit.
Yeah, it will be some traces left up, but all this radiation is okay, because like for example, right now here in our surrounding, we have background radiation also, which is somewhere around 30 to 50 counts per minute. Human beings have already adapted to this already, so we are fine. It doesn't matter to us. Okay, I mean, but of course you cannot have too long of a half-life, because if it's too long, then it'll take too long for that radioactive substance to decay to a safe amount. Then we're going to die eventually, right? So this one here a bit tricky. Let's write it according to the mark schema. Radioactive substance should not be longer than 6 hours, because it would be at dangerous levels in body. Oh my god, 太长了这个whatever 啦。It should not be short. Insufficient. Because doctors will not have, will have insufficient time to trace it. Radioactive substances should not be longer than 6 hours, because it would be at dangerous levels in our body. It should not be shorter, because doctors will have insufficient time to trace it. Something along the lines. Okay. And last part here, complete this. What's the number for a beta decay? 0 and -1. Yeah, wait. 0 and -1. So what number should this be? 99 and 43. Good.
What's the 43?
Because it's 42 minus -1.
2 minus -1. Oh.
Right. Then finally, they say that Palladium-99 is a radioactive nuclei. State another use of radionuclei in medicine. The most common one is obviously going to be what? Cancer. Very good. You know, all the radioactive therapy, right? Have you guys heard of it before? It's basically to combat cancer cells. So it's just say cancer treatment. But
The exact term for it.
what's the exact term of what?
Cancer treatment.
What's it called? Chemotherapy and what's it called? Radiotherapy. Yeah, I think it's radiotherapy.
If you put so exact, also kind of like.
Yeah. Okay.
Ultrasound.
Ultrasound is for baby one.
Yeah, ultrasound is using waves, right?
Yes, it's using
Doesn't-
high frequency waves. Ultrasound, basically. Okay. And that concludes everything in this class paper. Yay! Good luck for your exams on 19th. There's still class tomorrow, guys. Please make sure you still come out with us. We are going to continue with the new chapter tomorrow already, guys. All right. I'm going to move on and let Gilbert take over for MS. For those who are online, wait for the Zoom link. He'll be sending it shortly. All right, guys. That'll be it for today. I'll see you all tomorrow. Bye-bye. Oh my God.